Okay guys, we're going to do 9.5. Let's look at the warm-up. Please try this by yourself. Put me on pause, and then when you're finished, resume, and we'll see how you did with it. Okay, go ahead and put me on pause, please. What is the sum of this fraction plus this? Now remember, sum means to add. So we're literally going to add these two together. So I'm going to do the work down here. Notice that the denominators are always the same, and whenever you add or subtract fractions, your denominators have to be like. So they are. So let's go ahead and add the numerators. That'd be negative x plus 7. Adding the other numerator would be 2x plus 5, all divided by the common denominator, which is 2x plus 4. Combining our like terms in the numerator, we have the negative x and the positive 2x are like terms, and the 7 and the 5 are like terms. So negative x plus 2x is 1x, plus 7 plus 5 is 12, all divided by 2x plus 4. Okay, if you look at the, nope, I guess they didn't go any farther than that, x plus 12. I was going to say we could try factoring out the 2, which would be like that, but they didn't leave the answer like that. So they left the answer just like this, which means the answer is x plus 12 over 2x plus 4. So there is the actual answer. All right, let's go ahead and start 9.5. Oops, I went too far. 9.5 is completing the square. I know when we were doing factoring, some of you guys were getting frustrated with the ones where the leading coefficient was larger than 1. This is actually a strategy that will help you with some of those quadratic equations that are not easy to factor. It's called completing the square, and you really have to get the method down well before you feel comfortable with it. So one of the ways we figured out was to find the square roots. That's when the bx term was missing. Factoring, you guys have done plenty of that, whether you're factoring out a GCF or you're just factoring a trinomial or difference of perfect squares. And then completing the square is nice because it's always going to work. It doesn't always mean it's going to be easy, because if ever the leading coefficient is larger than 1, it might be easy if all the numbers are divisible by that number, but if they're not, then it's going to make it harder, and I'll show you what I mean when we get to it. Here's our strategy. If factoring is not possible, because some of the quadratic equations are not going to be factorable, then try completing the square. If this actually becomes hard, you guys are also going to learn how to use the quadratic formula, which I'll show you in a later lesson. But you're going to put the equation into a different form. It's not going to be ax squared plus bx plus c equals 0. Now you're going to get it set equal to c. Okay? And the leading coefficient has to be a 1. If it's not, say if it was a 2, you'd have to divide every one of these terms by 2 to turn this into a 1. We'll do one like that in a little bit. Divide the b coefficient by 2 and square it. So this is a method. You take the b, whatever your number is right here, you divide it by 2 and you square it. You take that number, that answer, and you're going to add it to both sides of the equation. So you're going to add it to the left side and the right side. What that's going to do is it's going to turn your left side into a perfect square trinomial. Okay? And then you're going to rewrite it using the squares. Then you're going to square root each side. Don't forget you have plus and minus whenever you take the square root, and you're going to solve for the variable. So get this process down, because I simplified up what the text says and try to get it into a more systematic, less writing strategy for you. Okay, so if I'm going too fast, please go ahead and put me on pause. All right, let's look at this example. This example is already set equal to 0. The question is it factorable? Some kids are going to try to factor this. Now, even if it's factorable, completing the square will still work. I'm going to go ahead and do completing the square for the sake of this lesson, because that's what we're learning. Now, when you do completing the square, don't forget it's got to be ax squared plus bx, and you've got to set it equal to the c. So that means we have to subtract 16 from both sides. That's going to give me x squared minus 14x is equal to negative 16. Once you get it into this form, then you find the b. The b is a negative 14. You take the negative 14, you divide it by 2, and you square it. So negative 14 divided by 2 is negative 7, and you square negative 7, which gives you 49. take the 49 by the method, you add it to both sides. So you add it to the left side by putting plus 49, and you add it to the right side by putting plus 49. I almost forgot, don't forget, remember the leading coefficient was a 1, so because that was a 1, we didn't have to divide out like the next one we're going to have to. Once you add that to both sides, you should recognize that the first term and the third term of the trinomial is a perfect square trinomial, which means you can factor it. It's now allowed us to factor it. So we get x, square root of x squared is x and x, the square root of 49 is 7 and 7, and you need same signs to get positive, and you're going to have to pick the minus minus. So if you were to FOIL this back in your head, do a mental check on FOIL, you would notice that it would FOIL back out to this trinomial. Negative 16 plus 49 is 33. Now, x minus 7 times x minus 7, another way to write that would be x minus 7 squared, which we talked about in earlier lessons. You want to write it like that because the next step you're going to do is you're going to get rid of the squared. The inverse of squaring would be to square root. Make sure you do it to both sides. So that's going to now give me x minus 7 is equal to the square root of 33. We're solving for x, so add 7 to both sides. Understand 33 is not a perfect square. So therefore you'd have to leave it under as a radical. So we get x is equal to 7, and I forgot my plus or minus the square root of 33. So that's actually my two answers. The first answer is 7 plus root 33, and the second answer, if I broke it apart, would be 7 minus the square root of 33. So you could write them out like that, or you could just do plus and minus, which is what math-minded people like to do. Okay? That's completing the square. All right, let's try. You might want to repeat me and go through that back again in case you didn't get it. Now, what happens if a does not equal 1? Like, for example, it's not equal to 1 right here. So what we're going to do, first I'm going to get it in so it's set equal to c. So I'm going to go ahead and divide this out. That's going to give me 3x squared plus 8x is equal to 100 minus 4 is 96. Now, I need to get my leading coefficient a equal to 1. I can turn it into a 1 by dividing by 3, but if you do that to one term, you have to do it to all terms. So that's going to give me x squared plus 8x divided by 3, this is yucky, is equal to 32. Now, take your b, once you get it into that form, you're going to have to take half of b. This is where completing the square is actually not the most favored method, and after I teach you quadratic formula, you probably would prefer to do it that way, because you have to take half of 8/3, in other words, you got to take 8/3 and divide it by 2. Okay? Or another way you can write that is 8/3 divided by 2 over 1, which was written as 8/3 divided by 2, which is the same thing as 8/3 times 1 over 2. Okay, that would simplify with this, and that would give me a 4. We'll end up with 4/3. Once you take half of it, you have to square it, which gives me 16 over 9. Don't change this to a decimal, because 16 and 9 are both perfect squares, and that's the whole point of doing this. So that's going to give me x squared plus 8x over 3. You're going to add the 16/9 to the left side, and you're going to add the 16/9 to the right side. Now, notice that your first term and your last term of your trinomial are perfect squares. So I can actually factor this to the square root of x squared would be x and x. I need same signs, both plus, and the square root of 16 over 9 is the same thing as saying what's the square root of 16 and what's the square root of 9. That would be 4/3. is equal to. Now, I need to figure out what this comes out to, which means I'm going to have to go back to what we learned in elementary school. That would be, you need common denominators. The common denominator is going to be 9. This one already is a 9, and you're going to want to take your calculator, and you're going to want to say multiply 32 times 9, which is 288. And then 288 plus your 16 comes out to a miserable fraction of 304 over 9. So we're going to set that equal to 304 over 9. Don't divide that out because it doesn't come out even. So now we're going to write this as x plus 4/3 squared is equal to 304 divided by 9. Okay? Now, in order to get rid of your squared, use square root. That will cancel this, but you gotta do it the same over here. So that's going to give me x plus 4/3 is equal to the square root of 304 is not a perfect square. So therefore, you're going to leave it as the square root of, we could write the square root of 9, so it would be the square root of 304 divided by the square root of 9, which would be 3. We can't do anything with this guy. Solving for x, we would subtract 4/3 from both sides. I am definitely running out of room here. That will cancel, so we get x is equal to, don't forget my plus and minus, so we get negative 4/3 plus or minus root 304 all over 3. You actually, because the denominators are the same, you actually could leave and just do one fraction bar and put it over 3 instead of writing it twice. You can do it either way, it's not a big deal. You may see it both ways. Okay, so looking at this problem, completing the square wasn't a very, it didn't make the problem any easier at all. And actually, guys, after I teach you the quadratic formula, that would be the way to go with it, is the quadratic formula. Completing the square is nice when you can get your b term, your b coefficient, to be a nice, a non-fractional number, and then it would make this problem a lot easier for us. Okay, but the process still can be used. It just makes it a little bit harder.